Welcome to The Explainer. Today we're going to talk about two of the most basic, fundamental forces that shape, well, everything. We're talking about the power to build things up and the power to break them back down, all at the molecular level.
So, let's kick things off with something you've probably never thought about. You know when you whitewash a wall? That simple white coat isn't just drying. Nope, it's actually performing this amazing chemical trick, and it's turning into something way harder, way more durable.
And it's all thanks to what we can call a building up reaction. This is like Chemistry 101, right? It takes simple stuff, in this case from the whitewash and just the air around it, and combines them to build something totally new and a lot more complex.
All right, let's really get into this whole building up idea. In chemistry, there's a proper name for it, a combination reaction. And believe me, it's happening literally all around us, all the time.
You know, the rule here is actually super simple. You start with two or more separate ingredients, we call those reactants, and they react to form just one single product. That's it. Multiple things go in, but only one thing comes out.
Okay, so check out this classic demo. You take some quicklime, you add water, and they combine to make a totally new thing called slaked lime. But the really cool part, the thing you have to pay attention to, is what happens next. The beaker gets warm. And not just a little warm, it can get pretty hot. This tells you it's not just a simple mix, right? It's a real chemical reaction, and it's releasing a ton of energy as heat.
That heat? That's the telltale sign that energy is being released as new chemical bonds form. There's a name for this. It's called an exothermic reaction. And this doesn't just happen in a lab beaker. Your own body is an absolute master at this.
Seriously, every single breath you take is fueling a massive exothermic reaction inside you. It's called cellular respiration. Your cells are taking glucose, sugar from your food, and combining it with the oxygen you just breathed in. And what comes out? Carbon dioxide, water, and, this is the whole point, the energy that is literally keeping you alive and warm right now.
Okay, so if chemistry is great at building things up, it only makes sense that it's got to have a way to take them apart, right? So let's flip the script and look at the opposite, decomposition reactions.
And you can see here, it's a perfect mirror image. A combination reaction takes A plus B and turns them into C. Decomposition, it does the complete opposite. It takes that one complex thing, C, and breaks it back down into A and B.
But here is the absolute key difference. Remember how our building up reaction gave off heat? Well, breaking things down almost always needs an input of energy. You have to put energy in to get it started. We call this an endothermic reaction because it has to absorb energy from whatever's around it.
So, where does that energy come from? How do you actually do this? Well, chemists basically have a standard toolkit for the job, and it comes down to three main tools: heat, light, and electricity.
The first and most common tool is just plain old heat. When you use heat to break something down, it's got a fancy name, thermal decomposition. And you can really just think of it like you're shaking the molecules so hard with all that heat energy that their bonds just can't hold on anymore and they fall apart. A perfect example of this is when you heat these green ferrous sulphate crystals. You start heating them and right away you see the color change as water starts to escape. Keep going and the compound itself just breaks down. And you can even smell it. It releases gases that have that really distinct smell of burning sulfur. Just like that, one substance has broken apart into three.
All right, tool number 2 in the chemist's toolkit is light. Yep, the energy packed into photons of light can actually be just enough to snap certain chemical bonds right in two.
So take this stuff, silver chloride. It's a white powder, and in the dark, it's perfectly happy, totally stable. But as soon as sunlight hits it, bam! The light provides the energy to break it down into solid silver, which looks gray, and chlorine gas.
And get this isn't just some weird lab experiment. This exact reaction, this light-sensitive breakdown, was the magic behind old-school black and white photography. The parts of the film that got hit with the most light created the most silver, and that's what made the dark parts of the picture. Pretty cool, right?
Okay, and that brings us to our third and maybe most powerful tool, electricity. You can actually pass an electric current through a substance to literally force its bonds apart. The process is called electrolysis.
And the classic example here is splitting water. Now, H2O molecules are held together by really strong bonds. They don't want to come apart. But if you pass an electric current through the water, it provides way more than enough energy to just rip them apart, separating the water back into what it's made of, bubbles of pure hydrogen and pure oxygen gas.
Okay, so that's the theory.
We've got the builders and the breakers. But how does all this stuff actually show up in the real world, in our daily lives?
Let's circle all the way back to that whitewashed wall we started with. So over a couple of days, the slaked lime in the whitewash literally grabs carbon dioxide right out of the air. It combines with it and forms this thin, hard, shiny layer of calcium carbonate. And you know what calcium carbonate is? It's the exact same chemical that makes up marble. You're basically creating a micro-thin layer of marble on your wall.
And once you know what you're looking for, you start seeing these reactions absolutely everywhere. We use decomposition, breaking things down, to make the cement for our buildings. It's how old cameras worked. And at the exact same time, combination reactions, building things up, are powering your body as we speak and giving that wall that tough, shiny finish.
So what's the big takeaway here? What's the main idea that ties all of this together?
It's this: our whole world is shaped by this constant dance between building up and breaking down. Chemistry isn't some abstract thing in a lab. It's this non-stop, dynamic cycle of things coming together and things falling apart. And that shapes everything from the ground we walk on to the very energy that lets you think.
And that really leaves us with one last thing to think about. We've seen how these reactions build our houses and power our bodies. But what other invisible chemical reactions, what other parts of this constant dance of building and breaking are shaping your world right now?